Spontaneous and non-spontaneous process. It is a common experience that water always flows from the higher level to a lower level by itself. We do not have to make any effort to flow water from the higher level to a lower level. But if we intend to take water from a lower level to a higher level, an effort will be required and we will have to spend energy in some form or the other. A spontaneous process may be defined as follows. A process which proceeds of its own accord under a given set of condition without any outside assistance is called a spontaneous process. Example, the flow of water from a higher level to a lower level. Non-spontaneous process, the process which can proceed neither by themselves nor by initiation is called non-spontaneous process. The transfer of water from lower level to higher level. Second point, entropy. A spontaneous process is always followed by an increase in the disorder or randomness of the system. In order to understand this disorder or randomness, let us consider two gases. Mixing of two gases is a spontaneous process. Suppose we have two containers A and B. These are the two containers A and B, connected together through a valve C. This is the valve C. That means two containers are connected by means of the valve C. Suppose the container A is filled with helium. This A is filled with helium. And the container B, this is the container B, is filled with argon. When the valve is open, the two gases mix together spontaneously. That means the helium will come here and even argon comes here. Therefore, a mixture of helium and carbon in both the container. Before mixing, the two gases were orderly filled in their respective container. Before mixing it, only helium here and only argon here, and there is an orderly arrangement. But when it is mixed, the order is lost and there is a disorder is created. This is called a disorder, a mixing up of helium and argon. After mixing, the two gases occupy both the container. Thus, the disorder or randomness has increased to as each gas can occupy larger volume. First, helium can occupy only this much and argon can occupy only this much. Whereas when the tap C is open, this full space that can be occupied by the helium and even argon. Therefore, the randomness or disorder is increased. In order to measure the disorder or randomness of a system, a thermodynamic function called entropy has been introduced. It is a state function and is represented by S. Entropy of a system remains constant if it is not undergoing any physical or chemical change. That is, the system does not involve any exchange of heat. When heat flows into the system, the entropy of the system increases and vice versa. Fill in the blank question. For a reversible change, the change in entropy delta S is defined as follows. Delta S is equal to Q reversible by T, where Q reversible is the heat supplied isothermally and reversibly to the system at a temperature T. Isothermal means at constant temperature. Like internal energy, entropy is also a state function. Therefore, change in entropy, that is delta S, depends upon initial and final states of the system. That is, delta S is equal to entropy of the final state minus entropy of the initial state. For chemical reactions, delta S is equal to entropy of the products minus entropy of the reactants. The absolute entropy of a substance at 25 degrees centigrade and 1 atmospheric pressure is called standard entropy of the system and is represented by S0. Units of entropy. The change in entropy, that is delta S, is an extensive property and depends upon the number of moles of a substance present in the system. The properties can be divided as extensive and intensive properties. Extensive property means it depends upon the matter, for example, number of moles. Intensive means it is not depending upon the matter, for example, temperature. If you have 10 ml of water and if you have 100 ml of water, temperature can be measured. That means it is immaterial of the amount of matter. It is usually expressed in units of joules per Kelvin per mole or calorie per Kelvin per mole.